My name is Winnie Haemba. I work as an adaptation researcher. I'm based at ICPAC and I work for an organization called Climate Analytics. So it is a delight to have all of you joining, and we look forward to very fruitful discussions today and some insights on what to expect and also what some of the implications are. Just to set the scene, on the Super El Nino topic. The El Nino is basically a natural climate occurring cycle that starts off in the Pacific Ocean, where in different cases, the sea surface temperatures become warmer than average. So that means they increase beyond what is considered the normal. And when this becomes exceptional, then it is referred to as a super El Nino, and that is a very simplified explanation of what a super El Nino event is. And the current focus for the year 2026-2027 show that we would be looking at this type of extreme event that might lead to devastating impacts in different regions of Africa. In Eastern Africa, for example, this could result in flooding in different countries. In Southern Africa, in some countries, it could mean extended drought and so on. And all these could lead to displacement of people, loss of lives and livelihoods, loss of livestock, even disruption of food supply chains, disease outbreaks when you have flooding, for example, especially for waterborne diseases such as typhoid, cholera, and so on. You could also experience infrastructural damage, among other impacts that are likely to occur with a super El Nino event. And so to take us through this discussion, I would like to welcome our first speaker, Mr. Pierre, who will kick off the discussions with us today. So, Mr. Pierre, please, you have the floor. Mr. Pierre is from the ACMAD, the African based climate center. He will speak about understanding Super El Nino and touch on the latest global forecast, specifically talking about what differentiates a Super El Nino event from a regular El Nino event. The floor is yours, Mr. Pierre.
Good morning, everyone. So my name is Pierre Kamsutamo. I work at ACMAD as the senior thematic expert in terms of forecast, and also I'm the team lead of the Climate Service and Application Project, CLIMSA project there at ACMAD. So today, as Uni have well introduced to you, today we are looking at that what is called, that strong El Nino, upcoming El Nino event that is expecting. We have already started seeing some of the prerequisites for that phenomena to occur toward the end of the year. So we are here to talk about it a bit, to discuss. So I was charged to present, to talk a bit about the global stature of the ENSO, and maybe I'll also introduce you to some of the other drivers and to see why this one is particular. So first of all, sorry, I'm trying to move here. So first of all, I would like to introduce you a bit about ACMAD. So ACMAD is the African Center of Meteorological Application for Development. It was created since 1985 and is operational since 1992, and is recognized as a WMO Regional Center for the whole Africa since 2015. And also is also the Continental Meteor Advisory Center since 2021, within the framework of AMOA. So our vision is to, I'll go mainly on our mission. Our mission is to act as the African Weather and Climate Watch Center and Center of Excellence for the application of meteorology for sustainable development. So this is our core area. So we work on agricultural health, climate for health, agriculture, and disaster reduction. So we're in charge of monitoring and focusing on early warning from extreme events. That's the one that we are here for. We also have to contribute to the different situation reports within the framework of MWAS. We also have a mandate to build capacity of African National Meteorological and Hydrological Services, and we are doing some research for operation, and we are also working toward the transfer of technology from the global center to Africa, and also from the regional center to the rest of the continent. Mainly, I wanted to talk about the global state of the driver, where the projected state, and also then I will present you a kind of summary and the potential implication of the expected situation over the continent, and yeah, or maybe we'll also put it in some of the historical context. Jumping directly here, so for us, what you need to know is that for the seasonal forecasting, because of where we are here, the main driver is the ocean, and which is used among the different centers. So for that one, we are monitoring the ocean. We're also looking at the projected state of the ocean for the upcoming month and season two. That's what is helping us to predict the climate around over the continent. So it's just one of it is, but this is the main driver. So what we are doing here, this is just the map of the sea surface temperature anomaly observed since the past. So I will start here since January, but we can even go back to August to see that from on up to let's say the last 3 months, what we have up to February, we had a below average temperature. So that means that the negative anomalies over here over the Pacific area, because this is one of the major area that we are monitoring. So that's what we had over that area. And when you look at it, what is happening is that since the beginning of February, we are moving into the above sea surface temperature over that area, and you can see through the maps when you look at the last 30 days. So something is building up over that area, over the Pacific, because this is one of the area where we look at the ENSO. So we have different areas that we monitor over the ocean, the Indian Ocean, but now we are focusing more on this one. We are also looking at the other part. You will see that even over the Atlantic, something is building up near over the western part of the Indian Ocean. Also, something is building up. So we also start to see let's say warm condition are building up over those different parts of the oceans. So what we can say is that since mid-April, almost near to above. I mean, when you say near to above, it's like a positive temperature, positive anomalies, meaning that warming is persisting across most of the equatorial Pacific oceans. So this is the main thing that we have to take from here. We also have some over the Indian Ocean, even over the Atlantic Ocean also. I was talking to you about those different areas that we have over the Pacific, over the Indian Ocean, over the Atlantic. So the main of to monitor that well, we have something that we are focusing on, which is the Niño 3.4 indexes. This one is just to display to you what is currently what is ongoing there. I mean, it's the time series of the evolution of that index over the ocean. So you will notice that when we are what we call positive. So when we are above zero is when we are like building what is called El Niño condition. When we are below, we are building what is called La Niña condition. So, but usually what is used to identify as La Niña or El Niño is when the index is below, for example, minus 0.5. That's when we're talking about La Niña. When it's above 0.5 positive value, then we are talking about El Nino, for example. So what we have here is that the trend, since that as I'm talking to you, that the current situation is that we are moving up into the positive area. So that's what we have here at the end. Regarding the what is called the IOD, Indian Ocean Dipole, that is the difference between the western and the eastern part of the Indian Ocean. So we look at those index because that this has a huge implication over the equatorial Africa. also. So we are also monitoring what is happening there. So this is the index that we have there. So what we say is that now we are kind of in the neutral condition. So yeah, we have a kind of neutral condition for that one. Here is just the what I'll call the projected status. So I'm just going there right away to show you exactly. So this is a map which I derived from WMO Lead Center. So when we look at it, the thick black curve here is the current observation, and then the color that you have here is the projection. So as I told you, is that when we are above, or when you're in this category, above 0.5 is when we are talking about El Nino. When we are below, we're talking about La Nina. So you will see that, as I told you before, is that before that, before February, we were in negative. We had like negative anomaly of SST over the Pacific. And then since then, we are steadily moving up to reach the positive side. So here we are in April, and we are almost reaching the um, 0.5 value there. So when we look at it, most of the model are predicting that the upcoming month toward the end of the year will be above that the SST, that the sea surface temperature over the Pacific, although the Pacific area will be above 0.5, meaning that we'll be we will be in El Nino condition. So we have a kind of strong El Nino condition starting up, let's say by June up to the end of the year. It's going to stay there. Looking at the Indian Ocean, the dipole index. So this is what we have. So what we have, I told you that we are kind of in neutral condition. So what is expected is that maybe by what we have, most of the models are projecting, let's say, neutral condition towards July, and from there in August, we'll likely move into the having like positive IOD with strong implication over for the rainfall for the fall rainfall over the eastern part of Africa. When you look at the other area, like the tropical North Atlantic area, we have like most likely the neutral condition there. The same for the southern part of the Atlantic, also like neutral condition toward the end of the year. So what we have to keep in mind is that according to the models. So we have not just the model, according to the situation, even observe and where we are the trends, which is the expected trends, we are moving to have ENSO playing a major role. And let's say by September, we will have a kind of addition of Indian Ocean, the Indian Ocean dipole on it also, meaning that the effect will be coupled, and maybe we are expecting like a very extreme condition over affected area that those index usually impact that those sea surface temperature usually impact. We have most West Africa, we also have Central Africa, Southern Africa, even the entire continent usually affected by the behavior of those area of the ocean. Here, I'm doing here focus on the ENSO index. So what is happening over the Pacific, because that's one of the major concerns. Is one of the biggest driver when it's in place. Control almost everything around the globe. So for that one, I put back the map that we have here. So this is just different plot from different centers. So here we have, for example, the Bureau of Meteorology of Australia. So what they are projecting also for that period. So most of the most of their model, because they are within that area, and they are known. I know that it's a center which is also in charge of monitoring what is going about the ENSO situation. So what we have there is that they are in line of projecting a kind of El Nino episode toward the end of the year. So when we look at the IRI, that one is like combination of a dynamical and even statistical model. You see that most of the model are projecting the American model, North American model, are projecting kind of and so rainfall above. Sorry, rainfall above 0.5 degrees C. Looking at what is called the, sorry.
Kindly wrap up.
Yeah, well, so looking at what we have over the same thing is happening. So most of the model around the world, looking at the Copernicus database, are projecting that trend, even if the spread, the spread seems to be big, but all of them are showing that we are moving into the I would say, to the weak to strong El Nino episode. So why do we think that this thing is going to occur? So here I just want to show to you what is called the in terms of subsurface temperature departure in the Pacific area. So what we have here is just let's say is the heat content of the ocean. So what we are having is that when you look at it, is that since December, even since September, we have a kind of building of heat, which is just ongoing all over the Pacific. So toward January, so we are moving here into the positive areas. That doesn't mean that the heat content is becoming very high. When you look in April, yeah, so you see that in May, where we are currently, it's really building up over that area, over the equatorial Pacific, where in the predominant El Nino area, where you look at the subsurface, what is happening under the water. This is what you have. So this is just the depth under the water. So this is the water surface over there. So when you look at different areas, you will see that we have a kind of strengthening of the situation. So a kind of warm pool over that area. So based on that, this is the statement which is made about ENSO. So what we say is that the La Nina condition that we were having is uh, about to end, and then we have to care about El Nino now. So this is the prediction that you have. So by the end of June, we have a switch between I would say, the neutral condition to the above normal condition. So here we are by the end of June. So in July, we'll start. So for the remaining of the season, we'll start to see kind of a high chance of having, uh, when you look at the red bar, high chance of having above normal condition, meaning it's a sign for ENSO. Now, when you look at this the specification that you have is to talk about. So when you look at red, you have light red, mid red, and strong red. Is just to talk about the strength of probably of what is expected there. So most of the model are agreeing that we will have an El Nino event toward the end of the year. Then some of them now moving toward the end. So what we have is that we have a high number of models who are pushing towards saying we have a strong El Nino condition over that area. So these are the value of the index which are giving us for those persistent conditions over the Indian Ocean. So by the end of the year, the chances are almost split above the 4 category, meaning that we are getting there. We'll get there. Will be by August. It will be into El Nino condition already. So it's likely to emerge with those amount of chance. So this is just some of the implication of what will happen. So here, the area of concern, depending on the season and the category of El Nino that will be observed, that is expected. So when we have like strong, when you have like moderate, here, for example, we couldn't find any year in JJL with moderate conditions. So, but if you have maybe other data set can show it. So we have like, these are the potential impact. But to be clear is that we are going toward having like reduce amount, a huge impact on the rainfall over the continent for the upcoming season. Then this is just to put everything into the context. So here is just that we have plot the black curve is just we have plotted the current observed with the mean forecast with the forecast of temperature over the Pacific. So we are looking when you look at the vertical red bar is just on the left we have observation, on the right we have the forecast. It's just to show okay this is where we are moving, and we have tried to compare the same period over the years to see okay which year was like this. So we talk here about the analog here. So here we have a kind of when you look at the 97 seems to be very close. We have another set which is 2022, 2023 for that period. So this is like this year seems to it's like it's playing the disc of those years. It's playing the same disc like those previous years. So we continue to monitor.
You're welcome, Eunice. The floor is yours.
Thank you so much, Winnie. So just a brief on who we are. ICPAC is a regional climate center designated by the World Meteorological Organization. We serve 11 Eastern Africa countries, 8 IGAD member states, and 3 East Africa states. Just a brief on the historical Super El Nino years. The key term now is Super El Nino, but I'll be having both Super El Nino years and just El Nino years. So like we've been told what a Super El Nino is, so I'll not repeat that. But what I want to just point out is what were the magnitudes of the index during the past Super El Nino years. So as we can see, I just indicated the past 3, the most common ones, 1982-83, 97-98, and 2015-2016. So we can see the Nino index during this year. These 3 years were way above 2 degrees above the average. Then when we talk of El Nino, specifically over the Eastern Africa and specifically over the during the October to December season, we normally talk about the Indian Ocean dipole because one, Indian Ocean dipole is a very critical modifier on how El Nino is going to impact the rainfall patterns over the Eastern Africa region during the October to December season. But we'll be focusing on both how El Nino affects rains during both the June to September season and October to December season, which are the 2 of the 3 main rainfall season over the Eastern Africa region. So the June to September season is significant over the northern sector of the region, while the October to December season is significant over the equatorial and the southern sectors of Eastern Africa region. So a general understanding of how El Nino impacts rainfall patterns during these seasons is that El Nino causes or leads to depressed rains during the June to September season and an enhanced rainfall pattern during the October to December season. So why or how does El Nino lead to depressed rains during the June to September season? A bit of science. So we have 3 key ways in which this phenomena leads to depressed rains. One is that it weakens the tropical easterly jet. Basically, the warm sea surface temperatures over the Pacific that we know we monitor the El Nino triggers what we call the Rossby waves, basically eastward moving waves, and that causes convective activities. So once these ones are triggered, it weakens what we call the tropical easterly jet, and therefore this weakened jet reduces convective activities during the June to September season over the northern sectors, and therefore that is one way that El Nino causes depressed rains over the northern sector. Then other way that El Nino causes depressed rains is because it reduces the moisture flow from the Atlantic Ocean as well as moisture from the Congo Basin. We have all been hearing about the Congo air mass and all that. So when we have this warming over the Pacific and all that triggered Rossby waves and all that, the low-level westerlies that is from both the Congo and the Atlantic are weakened, and therefore we have a low moisture influx into the region and therefore depressed rains. We also have the weakening of the East Africa low-level jet. This is also associated with the rains during the JJAS, but when we have El Nino happening, this low-level jet is weakened, and therefore moisture transportation towards the northern part of Eastern Africa is reduced, and therefore depressed rains. So this is an example of what has happened in the past during the 2015 El Nino event that most of us are quite aware of. We've seen that this was one of the worst drought years in the northern sector, specifically over. We've had a lot from Ethiopia, where most of the livestock and other impacts were felt. Livestock were lost, and other associated impacts were felt. And this is what we were able to see from what was recorded in terms of rains. So you can see central and to the northern part, specifically over the highlands of Ethiopia, were dry during that 2015. We also had dry conditions in northern parts of Uganda, which is basically an active area during the June to September season. We also had dry conditions in South Sudan and Sudan, also Eritrea. Then going into the October to December season, like I said, most of the time when we talk about El Nino or La Nina during the October to December season, we find ourselves talking about Indian Ocean dipole. Why? Because most often when we have an El Nino, it is associated with a positive Indian Ocean dipole, but there are other years when we have an El Nino and a neutral Indian Ocean dipole, but most often we have an El Nino with an Indian Ocean dipole being positive. So what happens during these years when we have a strong Indian Ocean dipole and an El Nino event? What happens is that most parts of the Eastern Africa gets enhanced rainfall. We have most parts of the region receiving significantly heavy rains. But when we have El Nino and no Indian Ocean dipole or a neutral Indian Ocean dipole, the wet conditions or the enhanced rainfall is only concentrated over the coastal areas, specifically over the eastern Kenya, coastal parts of Tanzania, and central to southern parts of Ethiopia. But if you go inland into the region, it gets a bit drier. So a case example of what has happened in the past when we had both El Nino, whether it's a super El Nino or just a strong El Nino, in 1997 and 2023, this is what we were able to record. The first map shows what was observed in OND 1997. And as you can see, most parts of the region, or basically like the entire region, recorded enhanced rains. And on the second map, this is what was observed in 2023 when we had a strong El Nino and also a positive Indian Ocean dipole. Most parts of the region also recorded enhanced rainfall, with only few areas in Ethiopia, Kenya, Rwanda, Burundi, Tanzania recording normal conditions. So that's all from us. Thank you so much. Over to you, Winnie.
So next, I would like to invite Seudu Tini from AgriMet to give us an overview of the West Africa region. Tini, the floor is yours.
Thank you, Winnie. Okay, good morning to all. So my name is Tini Seudu. I'm an expert meteorologist from AgriMet Regional Climate Center based in Niamey. I will not speak about. So let me present briefly AgriMet. AgriMet is one of the SILS institutions. SILS is the Interstate Committee to Combat Drought in the Sahel, which has its headquarters in Ouagadougou and has another center called INSA in Bamako. So SILS is composed of three main institutions with AgriMet based in Niamey. AgriMet stands for Agronomy, Hydrology, and Meteorology. And AgriMet is created in 1974 after the droughts that impact West Africa and the Sahel. So the mission of AgriMet is to collect, mandate, and disseminate climate, hydrological, and agrometeorological information across 6 member states to strengthen the technical and institutional capacity of national meteorological and technical partner, also to support food resilience in the region. So in terms of ENZO, the fundamentals of ENZO, my colleague already talked about it, but roughly is when we have cooling or warming over the Pacific equatorial basin, we are talking about El Nino or La Nina in this aspect, and it has impact on global circulation over different regions. In West African climate, when you have El Nino, it has an impact on the weather situation in the region. Mostly, it causes a suppressed rising motion in the region because most of our mechanism of weather is coming from the Gulf of Guinea area, where you have much air which penetrating into the continent, and it impacts the position of ITCZ or ITD over our region, which determine the harmattan or the monsoon over our regions. So by this, it has different impact in the Sahel, where we have when you have El Nino, it has impact the rainfall, where you have rainfall in the Sahel, but in some area like around the Gulf of Guinea country, we may have above normal rainfall situation. In terms of it has a teleconnection with atmospheric circulation, and when we have a stronger El Nino event, we have some convective heating ISOA into the Pacific, weakening water circulation and over Atlantic sector and modifying global atmospheric pressure distribution. In West Africa, the impact is it's disrupt the West African monsoon circulation, which will become weaker with the shift of ITCZ southward to be located over Gulf of Guinea country. And also we have the teleconnection produce different impact in the region. In the Sahel, we have mostly the drought condition over the Sahelan zone, and over the Gulf of Guinea, mostly at the coastal area, we may have increased rainfall situation that may cause flood in the region. In terms of historical El Nino events, we have this some years in 1982 to 83, 1977 to 98, 2015 to 2016, 2023, and 2004. And each of El Nino event have a different impact in the region. Like when you took 1981 to 83, we have a severe Sahelan drought amplification, which we experience intensifying rainfall deficit over the region, create a crop failure, famine condition, and livestock mortality. And the recent one is 2020-2024, where we have the El Nino, which occur with a rising global temperature, which contribute to a heat wave, flash flooding in some area, and hydrological instability, and also has 18 climate risk exposure across urban and rural community. So in West Africa, depending on where we are located, the impact of El Nino varies from excessive rainfall to drought, and also to flood situation over some areas. So in terms of what was observed specifically in terms of rainfall impacts and hydrological situation, we have some drought intensification, and we have some observation that have been observed during El Nino year, where we have, like when we take 97 and 98, we have in Senegal, we have severely affected, and some spots of moderate drought were recorded in Niger also and Sudan. When you take 2022-23, you have also a drought that affect seriously Senegal, Mali, most of the Sahelian countries. And we have some flood risk in the coastal West African, and we are seeing with different El Nino event, we are observing increasing the impact of El Nino in the sea level rising over our region. Also, over river basin, we have some impact. Mostly, we have main river basin, Niger, Senegal, Volta, where we have the indices is showing that at some time we have even in some place where you can cross the river by foot in our region for those years, like for 1984, where the river Niger was completely dry, and even in some area you do not have water in some areas. Also, in terms of agriculture and food security, the El Nino can impact the crop yield toward the reduction of this crop yield, and also it can create pastoral stress and livestock mortality in the region, like the one we observed in 1984 in the Sahelian region, where we have completely dry and animal was dying because of hunger and no rain, no food for them to eat. And also we may have some food prices volatility and humanitarian pressure in the region, which can lead to migration in some area. Also, when you have El Nino, it can impact health and societal effect with malnutrition, because when you don't have food, this will impact food security and also malnutrition in the region. And also we may have the development of some vector-borne disease and heat stress, which cause different type of mortality in the region, mostly for children and elders. Also, as I said, this impact can create a conflict, which we observe some dynamic conflicting because of this climate change or the impact of El Nino, which is increasing and also creating some migration different region. We have some economic implication when you have El Nino here.
Kindly wrap up.
Okay.
Kindly.
Okay, we have some economic deficit due to El Nino impact in the region, and how the map of this loss of GDP in the region. And also we have some damage in infrastructure, like an energy disruption, and also we have some different economic, like when we take fishermen, we have the different impact in fishermen road, and also many aspects of that. So what I can say that in terms of El Nino here, it has different impact over the region, and also the El Nino in our region can be amplified or can be reduced due to the impact of Atlantic Ocean, depending on the intensification of what happened on the Atlantic Ocean. And also it can increase the drought and heat stress intensity in the Sahel, but creating some flood condition over Gulf of Guinea region. And it has some major socioeconomic consequences and has vulnerability remain high in the region. So in terms of recommendation, we can recommend early warning system to become increasingly critical, with strengthen climate monitoring, seasonal forecasting, impact-based forecast, and anticipatory action, and also to adopt some adaptation and resilient investment are urgently needed in the region. So this is what I can say in terms of El Nino and its impact in the region. Thank you.
Yeah, thank you very much for your presentation. It's quite insightful to learn about the status with West Africa and some of the impacts that might come with this extreme event. Next, we will move to Southern Africa, and I would like to invite Sunshine Gameze from SADC to go ahead with a presentation. Sunshine, the floor is yours.
Let me share my screen, and I'll try to be as quick as I can, because the main interest is that the people who are connected to the webinar to get as much as they can from the discussions from us. So I think for me, I'll just take you through in terms of the implications in as far as the teleconnections between El Nino over Southern Africa. All right, so I'll go through these bullets as given here. I'll project something which has already been talked to by P and the others. I will not be talking to it, but I'll be showing it as a reference. So I'll show 2 slides, I think, or 3, related to El Nino, and then the current and the past, and then I'll talk to the performance over the past. Unfortunately, I'm failing to connect to our server, so I couldn't pull some of the what you call the maps to showcase what happened in the past, but I was able to get some from Matthias. He just shared now, so at least I've got something to share with you in terms of the implications, and then also try to attempt in terms of what is likely to be the case as we move towards the summer season. So CSC, as the other colleagues have also indicated, is formulated by 16 member states. As you can see there, all those countries from Angola to Zimbabwe. The center is currently under demonstration. As per WMO, we've submitted our request for designation, so we're waiting for the interactions with WMO on that part. So it might be possible that before the end of this year, we might be designated similar to, I think, agreement and worker. So the current state, as Pierre showed you, on the top left is the ENSO signal, which is showing you that we are moving towards a very strong ENSO signal, which is an El Nino signal, a warmer oceans. But when you look at the dipole, which Eunice talked to, when you look at the dipole, it's also showing a similar trend, but starting from July this year. So it is slightly delayed compared to the ENSO signal, as you see on your left. And then when you look at the other indicator that contributes to us is the Southern Atlantic Index, which will remain relatively neutral throughout the same period as given by the other maps. So this is just reference. Now, when you look into the past, I try to identify similar years which have got a similar start as this one, which are moving from an ENSO to an El Nino, and I discovered that there's none. The closest was they are way back into the past in the 70s, the 50s and the 70s. That's where you find a transition from La Nina to, so the closest that I could get was 1986, 87, which you can see there. You've got during DJF, I've got -3 moving, then becoming positive around JJA. So you can see there, so the years that are closely similar to the current year by magnitude, not by evolution, because that's what we need to also understand, because it's a webinar, it's a learning session. We look for evolution most of the time. We don't look for magnitude. But in this case, we don't have a similar year in the most recent history. So we are relying now on magnitude. So I've chosen 3 that I'll look to: 86, 87, 97, 98, and 2015, 16, which is most recent, as we have seen from Eunice's maps. So I didn't finish here. I'll finish before I submit. So I was just documenting for somebody who wants to read that the similar seasons for us in Southern Africa is the 86, 87, 97, 98, and 2015, 2016. So the global classical teleconnection is what you see on your left, which shows that classically Southern Africa should be dry when you've got El Nino and East Africa should be wet, and where Tini should be relatively dry. So that's the classical. But in terms of practicality, if you look at the map on your right, I think, am I having the wrong map? I wanted 86, 87, but I think my colleague sent me the wrong one. So let me move to the next one. The next one I think is correct. So if you look at these maps, you look at the one on the left and you look at the one on the right, you can see that there is indeed that signal of a dry signal persistent over, but it's not as it is shown there on the classical map, because you can see that some parts of South Africa, they've got some wet signals there, and also Mozambique, bulk of it in the south. There are some parts which are showing a wet signal, but classically, as you see there, it takes the same classical picture extending, which we see especially with the positive Indian dipole. It makes East Africa wet all the way, and so extending to Central Africa, especially Angola. You can see there, it's the signal as influenced by the positive Indian dipole. It gives us wet conditions over northern Mozambique, northern Malawi, Zambia, DRC, all the way to, so that signal is as influenced, as moderated by the what you call the positive DMI, which is the dipole. So, and also you can see for 2015-16, which was the most recent serious drought that affected us, you can see the signal shifts. It is not the same as you saw with the strong El Nino of 1997. You could see that the signal was in the central for that one. But if you look at this one, the signal is more pronounced over Madagascar, Mozambique, these coastal areas, east coastal areas, where it was more strong, and also parts of Botswana and South Africa. But you can see that there's a cut now between the two. So which means there has to be an influence for Angola from the tropical South Atlantic, and for Tanzania, I mean, for us, it means the Indian dipole was not as strong. So I'll try to add on this the signal in as far as the drivers are concerned, because you can see there was a break, because they usually connect in a typical ENSO situation. So this one, there was a disconnect, and there was local effects. You can see there over parts of South Africa and Namibia. There were local effects. So it's not just the global driver alone, but you also have local effects impacting. So in terms of actual impact on the livelihoods now, you could say that the 97-98 was the one that was deemed to be the biggest, but not necessarily if you compare with the 2015-2016. The 2015-16 was the biggest. But in terms of agricultural production, it really affected agricultural output. But some parts of the region, because I was at national level at that time, I know that in Eswatini and eastern parts of South Africa, there was a bumper harvest during that very same period, whereas it was anticipated to be very dry. So there was a need now for countries like Zimbabwe and Zambia to increase food imports, whereas Zambia and Zimbabwe, by then, they used to be the major growers together with South Africa for maize, until Malawi also joined in later on. So now, if we look into what is expected into the future, this is just for the next 3 months, you can see that the impact, the effect of the La Nina, the weak La Nina that we've been having all along is still there. That's why we're still having flooding effects, where we've got extreme weather events occurring over Eastern Cape of South Africa, around these areas here. There's people dying there, rivers, and also we have got in Cape Town, we've got, because this is the rainfall season now, we've got storm surges as a result of the effect of the weak La Nina that has just dissipated. You can see even temperatures in the next coming months, they are going to be relatively lower in as far as that is concerned in terms of the coming 3 months. So you can see that it's not just El Nino now just changing, twisting immediately. There's going to be a transition, which is what I was talking about earlier on, the evolution. The evolution is what we should all be focusing on as forecasters and also as users, because that's the question to users. Look at the evolution. Don't look at the numbers in terms of the index of El Nino, but look at the evolution. Are we evolving towards a very dry situation? Where are we coming from? So we must know that nothing just happened overnight and just because the numbers are high, then everything is going to be dry. No, not necessarily. So now the typical...
Kindly wrap up.
Oh yes, it's the last slide almost. The typical situation that is likely going to happen, I think I thought this was 86, 87, but I found it's 96, 97. But I will most likely go towards the 97, 98 or 86, 87 situation as the most likely over the region. And also caution is that the higher ENSO signal does not mean drier conditions over Southern Africa. But yes, we do anticipate that the effects will have parts of the region that will experience drought, but not entirely that it's because of the signal, because of the number being high, then it means we will have and also to emphasize that there's no season in the recent future that has got a similar evolution as the one that we are looking at, and that we must also take into account that there will be other drivers that will have influence on the teleconnections from the ENSO signal. Thank you, Chair.
Yeah, thank you very much for that insightful presentation. And there, I think one thing to take away is your emphasis on looking at the evolution. Indeed, this is quite important because normally this will always be different and no event typically is the same as the past one. These are all different depending on the various other situations, including IOD, MJO, as well as local factors, as you have explained. So now we will take a number of questions. And the first question we have here, that Super El Nino predicted starting from May 2026 at 61% until the end of the year. What is its implication for pastoral and agro-pastoral communities in East Africa and across sectors? And some of the sectors are listed here: agriculture, food security, education, nutrition, as well as others for preparedness and early action as a humanitarian actor for decision-making ahead of anticipated emergency. I think this question can be answered by Eunice.
Thank you very much, Winnie, and thanks, colleagues. I think we really have a lot of questions. So in terms of the question that someone asked in terms of impact, I think when we go into sectoral impact, this varies from country to country, from season to season, because we'll have areas that are getting depressed rains during JJS, but when you come to OND, the impact is different, that is enhanced rains and floods and associated impact. So, but what we will have is that we will be organizing another webinar that will really focus on sectoral impacts for the different countries and the different regions and the different seasons that will be able to answer all those questions on the sectoral impacts. Then I also saw someone saying, why do we use a very scary name of Super El Nino? I think super is just an English word. It should not be scary because what we've seen in what I presented, for example, we had a Super El Nino in 2015, but the impacts were not as were in 1997 or 1982, for example. So this is just a terminology basically because of the extent of the index that we are talking about. We are saying a Super El Nino would have a Nino index, or what we call the relative Nino index now, that is above 2 degrees above the average. So it's just to distinguish how strong it is, but the impacts does not really mean that they will be worse than what we had in the past. Like someone has said, there is no year that is as similar to the other in terms of impacts and all that, even if they are both strong El Nino years and all that. So the impacts will always be different, but the word Super El Nino does not mean the impacts will be stronger than what we've had in the past. Then, so for all the impact, for all the questions that are asking about the impacts, in terms of the impacts in terms of rainfall patterns, I think that has been clearly explained by the different presenters. But in terms of sectoral impacts, those are they'll be varying depending on the country, depending on the season. And like I said, we'll be able to organize another another webinar to answer very specific questions on the sectoral impacts. Winnie, let me give it to another person so that they are able to answer more.
Yeah, thank you. I think for the Q&A question, there is a need to give a specific answer in terms of if we are expecting dryness or wetness in the West Africa. That what I say that is in West Africa, the impact of El Nino varies. And if you take only El Nino, the impact is to have the dryness in the Saharan parts of the region, most of the region, and over Gulf of Guinea countries, mostly coastal area, we can expect it to have increased rainfall and even some flooded in some areas. But we know that in our region, it's not only the El Nino who modulates the climate condition. We have also the tropical Atlantic situation, which can contribute to attenuate or to enhance the impact of El Nino. So what was expecting for this year is that the tropical North Atlantic will be more warmer than the tropical Southern Atlantic. But right now it is neutral situation. But when we move to the season, we are expecting the tropical North to be more warmer than tropical Southern Atlantic. So this can contribute to reduce the impact of the El Nino over the Saharan parts. That's why in the seasonal forecast that we made last 2 weeks, it is expected to have a normal to above normal rainfall situation over the Saharan parts. So that's what I can say now about the impact of El Nino, but we need to combine it with the impact of also tropical Atlantic condition. Thank you.
So next, I would like to invite Sunshine from SADC. Please take the floor.
What I would probably just continue to share with the participants and all stakeholders, especially the users and other colleagues, is that please, the word Super El Nino is just a word that has been spreading around. We don't have that even in the categorization of El Nino or La Nina. We have got a strong La Nina or a weak La Nina. We don't even have a moderate. We just have a strong La Nina. And that is just a way of trying to assist in terms of understanding that the index is high. Not that it means the impacts are going to be even more than what it's usually seen in the past. It's just to help people to understand that we have got a strong or a weak La Nina. A strong La Nina or a weak La Nina, something like that. So that should not shock you. So Super El Nino, it's not a word that we're using, but it's good for us in terms of the webinar, that we look at it as it is being being portrayed in the media space, because that's what you will be getting in the media space. So In closing, I would just like to emphasize that in the different regions, irrespective of the what you call your so-called classical teleconnections, let's look at all the drivers, not just El Nino. El Nino is a major modulator of all the drivers. But like I saw one question raised by Peterson on the chart, is that if you have got the neutral IOD, what does that mean? Does it mean you are going to have a very strong El Nino, which is the so-called super? No, not necessarily, because what that means is that the IOD will not have much of an effect on the regional climate, which means El Nino will be modulating alone the what you call the other effects as a result of a specific IOD signal will not be taking place. Let me just end there, Chair. Otherwise, I think the discussions are very important, and as it is indicated that we may have another webinar, that would be very good, so that we can try now to look in terms of interacting with the users. I submit, Chair.
Yeah, thank you very much for that. Next, I think, and to wrap up, we will go to the speaker we had first, Mr. Kamsu, please. The floor is yours, and be very brief.
Yeah, I think I'll not say much more than what the other speaker already said. So, but what we have in mind is that, I mean, we are talking about we are focusing the event on the ENSO because, I mean, what is the signal seems to be strong of what will happen by the end of I mean, what is likely to happen. So we continue to monitor. So I've seen a lot of questions about what's going on exactly, the situation that we see, the way that the index are moving up. I mean, the situation, the temperature is moving up over the ocean. We are likely to stand that we base coupled with the forecast. This is the season that we have long ahead, so we continue to monitor, and when necessary, we will do the update. And as mentioned before, it's not just about El Nino, it's also about the other factor surrounding your area of interest, because I mean you need to really monitor what is happening there. This effect can what is happening in the vicinity, the direct vicinity of your area can affect directly let's say can intensify or reduce the effect of what is expected about the upcoming El Nino. So that's what I wanted to say, to continue to monitor. You have the regional centers, you have your national med services will give you the right update on the right time. So we're working closely with them for this situation, and we are continue to monitor. So as mentioned, we are also working on preparing a webinar to address the socioeconomic impact on different sectors. That's all for me.
Yeah, thank you very much. Thank you very much for that. And yes, one key takeaway is that we will continue to monitor the situation, and at future webinars, some updates will be provided about how this is evolving and what to look out for. We've also taken note of all the questions in the chat and also in the Q&A channel, and we will try to respond to these in upcoming webinars. As one of my colleagues already mentioned, we are planning future webinars to continue the discussions, and the next one will probably also delve so much deeper into the implications and so on, and we'll try to include the other regions as well, because I saw in the comment that Central Africa had been left out. So potentially in the next webinar, we will also cover these or at other platforms. So yeah, thank you very much, everyone. Thank you for participating in this webinar, and also thank you to our speakers today for your insightful presentations. This is an ongoing conversation, and we will continue with the discussions and to really monitor and see how this evolves and what it means for our region, so that we can adequately respond to it. So thank you very much. Presentations will be shared with everyone that registered for this webinar, and you can interact further with them. Thank you. I will close it there. That is the end of our webinar, and we look forward to having you again at the next webinar. Asanteni and goodbye.